Hello and welcome back. A few years ago I made this drag engraver for my DIY CNC mill and have been using it ever since quite successfully on several projects where I need to engrave on flat surfaces. But I also want to engrave on rotating or round surfaces, and that's not possible in my mill. And for that purpose I have a lathe also, but this drag engraver is just too large for my lathe, so I decided to make one specifically for that purpose. And the idea I have is something like this. I have some 48mm steel rods which I am planning to convert into a drag engraver, a quite compact, much smaller one than this one. This one is 140mm long from the tip of the engraver, the engraving bit, to the top of the tool, and it's 45mm wide. It's also specifically shaped for my mill spindle motor, the motor housing, so it can't be used in the lathe. But this one will be a round bar, and it will accommodate the small engraving bits I am using. The diameter of the engraving bit is 3.17mm, so of course there needs to be a hole for that. And then at the end there will be a retaining ring here, which is 8mm in diameter. Of course it will be drilled in for the engraving bit. Something like this. So this is 8mm, and then I don't know, maybe I will drill something like 6mm in here for the engraving bit, or maybe more, maybe 10, but I will see as I go along. And then the total length maybe will be something like 12mm or something like that. I don't know. I haven't made up my mind completely yet. But anyway, this will accommodate or hold the engraving bit, and to prevent it from falling out I will drill and tap M3 here. So this will hold the actual engraving bit inside here, and then after that there will be a spring which is 8mm in diameter also, and then the top will be threaded to M10, so it has to be drilled out for 8.5mm diameter, and then threading this part 20mm in, so that I can screw a spring tensioner in here, which can be used to regulate the spring tension, similar to this ring here regulating the spring tension, but the spring is outside in this case, because I just didn't want to print a very large 3D printed part just to hide this part of the engraving tool. So I just let it be like this, and that works very well on the much larger mill I have, but it will not work well on the lathe, so I have to do something much more compact, and I think this will be perfect. Of course, the shape of the rod is like that, so this part must be shaved off to form the pen like shape. And then of course for this M3 screw I will mill out a slot here so that I can change the end the engraving bits as I want to, anytime I want to, without having to disassemble everything. So that's it, these are the plans, and I think we can start. Now I can hear it cutting, and can also see So let's see now if it fits. Yes, it fits perfectly. So this is very good. Okay, so it's time to start chamfering the engraving end of the steel rod. This was very quick, and the results are quite nice. And now it's time for drilling. This end, which needs to be drilled to 8mm to accommodate this diameter, which is 8mm, and I will of course cut a piece of this and drill this to hold the engraving bit. So the drilling went quite well, and it's really a nice tight fit. Maybe a little bit too tight, but I will fix that if necessary once I have this insert ready, and I will see if it causes a problem. In that case, I will just make the hole a tiny bit larger. But for now, this is perfectly fine. So what I have to do now is to face this piece, and then I plan to chamfer at 60 degrees, because the drilling inside here, it's not really visible, but because I drilled with an ordinary drill and didn't make this end flat, so it is now at a 60-degree angle, and I think that is it's better if this retaining ring is also chamfered to 60 degrees. And then of course I will drill a hole for the engraving bit, and when everything is done I will part this off to be, I don't know what, maybe 8mm long. This is not very critical because it will be at the bottom of this, and then after that there will be the spiral spring and then the screw in this end. So now it's time for some brushworks. So now the last operation on the lathe will be the parting. I have already set up the lathe, and I will use my DIY jogging device to control the lathe, because I think that's easiest. And that's it. It actually broke off before I cut through, but it doesn't really matter. This is going to be perfectly fine. I just removed that tiny bit, and that's it. It's just need to drill a hole for a set screw, and I will do that outside in the bench drill machine. So that's it. It's almost done. Okay, so now it's time for a quick test. The engraving bit, or the engraving, the scratch engraver is now inserted in the tool post, and I will make a quick engraving in this piece of steel. And let's go now. The movement is not really optimized, but I am using freeware to generate the J-code necessary, so this is what you pay when you don't pay anything. So, all the work is done. and it turned out to be quite nice. It looks something like this now when it's ready, and as you see, the size is quite a bit different compared to the one I made for my mill. In every way it is much smaller, and as you have seen, I have done the test engraving on this round rod, and it turned out to be quite nice. I am very happy with the results, so this will be another addition to my set of tools. Yeah, moving the light improved the video quality a bit. So as you can see, it's very nice. Anyway, the lines are clearly visible, and also the letters when I am looking at it. So this will be very useful also. That's it for now. I hope I inspired some of you to make similar tools, and it was actually much easier than I expected it, and it turned out to be much better than I thought it will be. So that's it for now. Thank you very much, and goodbye.